Welcome back to the last lesson that you're going to be learning for this semester. What we're going to do today is something that you've done beforehand with similarity flowcharts, but today what we're going to do is flowcharts for congruence of triangles. And so just to kick things off, what we're going to do is we're going to kind of recollect the ideas that we developed yesterday and put them into a flowchart. If you look at these this set of triangles right here, we can conclude that by side, side, side congruence. Remember that these triangles are congruent, and that's the symbol that we use in order to talk about congruency. And congruent again means same shape and a scale factor of 1, or in essence they're the exact same. So when we make a flowchart, just like we did with similarity, since I'm using side, 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 what I'm going to do is I'm just going to create 3 ovals as such, and within each of these 3 ovals are going to be the 3 sets of sides that we are saying are equal to one another. And so that would mean that AB is going to be congruent or the exact same as FD. Those are the same. Another set of sides would be BC, which would correspond to DE. And then lastly, the last set of sides would be AC, and that corresponds or is congruent to side length FE. And as such, then, because of this fact, I can draw a conclusion which is indicated by these 3 arrows. And because of those, I can say that triangle ABC is congruent. So now when I list out the rest of my triangles, A and F correspond, FDE, triangle FDE, and I know that this is true by side, side, side congruence. So this is very similar to doing a proof like we would for similarity, no pun intended within that. But we list out all of the facts first in these ovals up here, and then once we've established all of those facts, then we can draw a conclusion, which is saying that those 2 triangles are congruent to one another. And so on the next slide, what we're going to do is we're just going to revisit some of those triangle congruence theorems again, and then move on to some more practice with flowcharts. If there is something that you should get down, if you haven't already, this would be the slide showing all of the different triangle congruence conditions with pictures. So we have side, 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 angle, angle, side, angle, angle, side, and hypotenuse leg. And I believe I went through each of those yesterday in the previous video as well. But you may go through and take these down and take a look at the different indications indicating how we can show the 2 triangles are congruent. And why these are useful, why these shortcuts are helpful, is because instead of going and showing that every side and every angle that correspond are equal, what we now can just do is take these sets of information, and if we just know those sets of information, then we can conclude the 2 triangles are congruent. And so what we're going to do now is we're going to apply this into some flow charts like what we did for similarity. So before we get to the flowcharts, what we're going to do is we're just going to try and justify whether or not these triangles are similar based off the markings, or congruent rather. This is kind of like what we did yesterday. With letter A, hopefully you can recognize that we have 2 sets of sides and the angle in between them. 2 sets of sides that are equal as designated by the tick marks, and the angle in between them. So we'd say that these are congruent by side, angle, side. Hopefully you can recognize here we have 3 sets of different tick marks, so by side, 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 these things would be congruent to one another. What I want to point out for letter C is that the side length here is not located in between the 2 angles. This is not located on this side length that is in between the 2 angles, so it is not angle, side, angle. In this instance, the side length would be in between the 2 angles that we are given. That is not the case in this set of triangles. This would be angle, angle, side. Students often misrepresent that, so I just want to clarify that issue as well. On this triangle right here, this would be an example in this triangle, letter D, of angle, side, angle relationship. Now, is that the same relationship that we have in this triangle? And the answer is no. Notice here how we have 2 sets of angles and the side length is not in between them. So we don't have the same set of corresponding information. So for letter D, we're just going to have to say not enough info. There's not enough information in order to draw a conclusion about those two sets of triangles based off the given information. Anytime that you see a right angle, just be leery of the ever-looming hypotenuse leg theorem, and that's why these two triangles are congruent. We have two sets of hypotenuse that are congruent to one another, and another set of legs that are congruent to each other, and a set of legs, or excuse me, a right angle. So by hypotenuse leg, those two triangles are congruent. And then lastly, these two triangles are congruent by angle, side angle. And so as a brief reminder at the very end, congruence theorems that don't work, so things that you need to be on the lookout for. We cannot use side-side angle, and that would be a set of triangles where you're given one side, another side, and the angle that is not included in between them. That does not work. And the other one that does not work is angle, angle, angle. So if you have two sets of triangles and all you know is three sets of angles are the same, that's not enough to show the triangles are congruent. So using this as the backdrop, now we're going to go and throw this into some proof. So problem number 31 says, make a flowchart showing that the triangles below are congruent. And at first glance, as I go through and I look at this, what I'm trying to identify is which theorem or which condition should I use out of those 5 from our list that we had to show that the triangles are congruent. And as I look at this, I have one set of sides that are equal to one another. I have a set of angles that are equal to one another. But that's not enough information. I don't have anything else. Side angle is not a sufficient way to show the two triangles are congruent. But we need to be a little clever here and understand that angles that are across from each other whenever two lines intersect are equal. Those are vertical angles. And so this angle is the exact same as that angle. So now I have two sets of angles and the side that is not included in between them. And so I can say, therefore, that the triangles are going to be congruent by angle, angle, side. And that's going to be my goal when I create my flowchart. So I'm going to have 3 ovals now because this is going to be angle, angle, side. And the 3 ovals represent one angle, another angle, and the set of sides that are equal. And so then within each oval, what we're going to do is we're going to list the set of angles. So this is going to say that the measure of angle P is going to be the same as the measure of angle T. Now for this middle angle right here, the one right here, R, I need to use 3 letters in order to name that because R can be rather ambiguous. I'm going to say measure of angle PRQ is equal to, or congruent, I should write congruent. Yeah, we'll just leave it like that for right now. Is congruent to the measure of angle TRS. And then the set of sides that we know that are equal, I would say that PQ is congruent to side length TS. And these are the 3 sets of information that I've identified that are equal to one another. And as such, all of these then point to a conclusion that the triangles are congruent, or they are the exact same. We use that shortcut of angle, angle, side, so I can say the triangle PRQ is congruent to triangle TRS, and the reasoning was by angle, angle, side. I had that set of information in order to justify that. All right? We're just going to do 2 more flowcharts. We're going to first of all identify within this problem, the last problem, that these ones are not congruent to one another. Hopefully you can recognize that 5 and 4 aren't the same, therefore those side lengths aren't the same and they're not congruent. What we're going to look at is letter A and letter D. I'm going to start with letter A here. Hopefully you can recognize again these symbols, which mean parallel. And if you have 2 parallel lines, that means that alternate interior angles, or these angles right up here, are equal to one another. And also anytime the 2 triangles are touching or overlapping, or they share something rather, for example, this side length right here, that's going to be the same side length within each triangle. So with my given information, I have an angle, another angle, and a side length, and over here I have an angle and another angle and this shared side length. So these 2 triangles are going to be congruent by angle, angle, side. And so that's a very common application that we'll see it. And then on the last one over here, and we'll do a flowchart in a moment, is to see that these two triangles at first look like they could be or could not be similar, but what we should recognize is that we can determine what this missing side length is, and that's going to be 12 if you can just do the Pythagorean theorem. And so since that's going to be 12, I can recognize that this is also going to be 5 here. And so I can say that these two triangles are congruent by side, 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 since they have 3 sets of sides that are equal. So I'll let you go through and try letter A if you'd like. I'm going to do letter D here, just as that's something different. Since I'm going to do side, 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 I have 3 sets of sides that are equal, so I have 3 ovals that I want to draw out. And up above here, I'm going to list the 3 sets of sides that are equal to one another. And so the first set of sides is, I'm going to say that ML is congruent to side length QP. That's one set of sides. Another set of sides would be KL being congruent to RP. And then lastly, the hypotenuse MK is going to be congruent to the other hypotenuse of QR. And because of that, the conclusion that we reach, that we've already written out, is that those two triangles are indeed congruent to one another. And the reasoning would be by side, side, side. So triangle MLK is going to be congruent to triangle. If I went to MLK, then I could go QPR by side, side, side. Beautiful. And there's a flowchart proof for what we're looking for that one. And I'll just finish this one up too, shouldn't take too long. I have 3 ovals again because I'm going to be using angle, angle, side. And so if I'm using angle, angle, side, I need to list the 3 sets of criteria. So the first angle that I know is equal in both triangles would be that the measure of angle D is equal to the measure of angle B. And the second angle, I'm going to say that the measure of angle DCA is going to be equal to the measure of angle DCA would be BAC. And again, I use 3 letters to name this angle, BAC, like this, which would imply this angle here, and DCA as well, just because if I just said angle A, that could imply the angle on either side of that line. So I just used 3 letters in order to help specify that. And the side length that's the same in both triangles would be AC. So AC is congruent to AC. And therefore, drawing the conclusion here, and why is that a Trojan blue and gold, would be that the two triangles are congruent to one another. So I can say that triangle DCA is indeed congruent to triangle BAC. And that is by angle, angle, side congruency. So make sure that you're using the congruent symbol here and not the similar symbol. But that's going to conclude our work for flowcharts and taking triangle congruence and putting them into flowcharts. And that's going to be the last bit of information that we're going to throw your way this school year. We're going to do some review for the next week afterwards. But if you do have questions before we take our test, please reach out, let me know, stop by the office hours. Stay safe and stay healthy. We'll talk to you soon.